Hello, 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 dear students. Myself Ajay Lakina, Faculty Mathematics at LN. I am going to teach you the topic geometry. It is one of the important topic in Mathematics Olympiad. Today I will teach you the main theorems of the geometry, and I am using some software here so that you can get the overview of geometry, that how geometry works. Later on I will give you all the proofs which I am using, all the lemmas, okay, and we will do the application of the lemmas and the theorems in problem solving as well. Okay, let's start our topic, geometry. If I can have any few points here, okay, I have taken any, I have just clicked a few points here, okay, I am just naming the points. Let the point be A, this is B, this point is A, this point is B, and this point is C. Okay, so what I am doing is, I am just selecting these 2 points and go through construction and join a segment here. Okay, AC is one of the segments. Then I join AB. Again, join AB, we get one another segment. If I join BC, we can get another segment BC. So here ABC is any triangle. If I have to verify that in a triangle all the medians are concurrent. Medians are the segments you can say in which we can join the one vertex to the midpoint of the opposite side. So first I select this line segment, then I am getting the midpoint of this line segment BC and name it as D. Okay. Again, I have selected this line segment, taken its midpoint and name it as, you can say as E. You can name it as E. Now I just selected this line segment, taken its midpoint and naming it as F. Okay. So in this triangle ABC, DEF are the midpoints and ABC are the vertices. So if I join AD, it is one of the median. Okay. Go to construct, just join AD. If I join BE, it is another median. Okay. And their point of intersection is called a centroid. So if I select these 2 lines and taken their point of intersection here, we get one other point and let us name it as G. Okay. So now in this triangle ABC, DEF are the midpoints, AD and BE are the medians. If I have to verify that in a triangle all the medians are concurrent, okay, so what should I do is, I just join CF. If it passes through G, it means all the medians are concurrent. I just join the segment. As you have seen, the line is passing through G. So if I take this point as A and drag it, you can easily verify that in any triangle all the medians are concurrent. You can take B to any other point, and everywhere you have seen that in a triangle all the medians are concurrent. Okay, easy. Hope it is clear to you. So if I have to verify that the center divides the median in the ratio 2:1, what I am doing is, I just selected AG and go to measure. I just calculated its length. Its length is 6.77 centimeters. I just join GD and measuring its length. Again it comes out to be 3.38 centimeters. If I calculate their ratio, that is AG divided by GD, it comes out to be 2:1. Okay. Some of you are thinking that it is 6.77 and it is 3.38. How it comes out to be 2? So for your kind information, I am just clicking this point, or you can say as, if I when I calculate this one AG, okay, if I remove this one, you can see easily that is what is happening here. Okay, AG comes out to be 6.76821. Okay, AG is 6.76821. So just actual length is 6.76821 and we are showing the length as 6.77 centimeter. Similarly, if I divide this by GD, okay, GD length comes out to be 2. Or if you, okay, if you want to measure the length of GD, it comes out with some terminating decimals. Okay, non-terminating decimals you can say. So AG upon GD comes out to be 2:1. So if you want to verify that whether G divided AD in the ratio 2:1 always or not, so you can verify here. As the length is changing, okay, as we are moving the point, you can see that AG and GD length are changing, but the ratio of AG upon GD remains constant. That is, AG upon GD is always comes out to be in the ratio 2:1. Similarly, if I measure the length BG, it comes out to be 7.33 centimeter. GE comes out to be 3.67 centimeter. If I calculate, it comes out to be BG. Basically, BG is 7.33165 centimeter divided by GE. It comes out to be 2:1. Okay. If you want to drag, you can drag anywhere, and you can verify that the ratio is always comes out to be same. I will give you the proofs as well. Okay. Today I am just verifying the important results for you. So go to CG. Its length is 10.8 centimeter. GF comes out to be equal to 5.19 centimeter. You can calculate the ratios as well. CG upon GF, it comes out to be in the ratio 2:1. Okay. Hope it is clear to all of you. The inner triangle ABC, if DEF are the midpoints, then AD, BECF are called the medians. Okay. And the point of intersection G is called the centroid. And centroid divides the medians in the ratio 2:1. So some more important properties of centroid are here. If I can select these points, okay, BGD, and if I can take their triangle interior, okay, and if I have to calculate its area, I just select this area, go to measure and find its area. It comes out to be 13.72 centimeter square. So I want to tell you that all the 6 triangles have the equal areas. If you want to verify, you can verify here as I just select C, G, D and C. Go to construct, making its triangle interior. Okay. If I want to calculate the area, I can calculate area as well. This is 13.72 centimeter square. Okay. Again, the area is same. And you know already the median of a triangle divides the triangle into 2 parts of equal areas. So in triangle BGC, GD is also a median. That's why you can say both the areas are equal. But now in this case, GEC, if I make the triangle interior, okay, and if I have to calculate the area, its area again comes out to be 13.72 centimeter square. Again, GEA, and if you want to calculate the triangle interior, and if you want to calculate its area comes out to be again 13.72 centimeter square. Again, if I am selecting these 3 points A, F and G, okay, you can go to construct, make the triangle interior, you can get their area as well. Okay, beta, this is B, F and G. I am making the triangle interior, and I can calculate their areas. You have seen that all the 6 triangles are equal in area. That is, you can say as area of a triangle BGC, area of these 2 triangles, or area of these 6 triangles are equal to 1/6 of the area of a triangle ABC, and area of these 3 triangles, this triangle plus these 2 triangles plus these 2 triangles are 1/3 of area of a triangle ABC. Okay, this is a verification, and we will prove all the results. Okay, beta, that is centroid divides the median in the ratio 2:1, and all the 6 triangles are 1/6 of the area of a triangle ABC, and you can say BGC, area of BGC is 1/3 of area of a triangle ABC. Okay, we will do some more important results. I am just erasing all these results now. Okay, so in this triangle, now you are having ABC is a triangle in which DEF are the midpoints. So I am erasing. Okay, you can keep them, no issues. Okay, so one more thing I will calculating here is I am just measuring their angles. Angle BAC comes out to be 76.36 degrees. Angle ABC is 69.25 degrees, and angle BCA comes out to be 34.39 degrees. If you want to calculate the angles on property, this is a basic one. You can calculate here. This plus this plus this. It comes out to be 180 degrees. Okay, you can keep anywhere. You can see that whether I can make any triangle, whether it is acute, whether it is obtuse. That is, if I can make angle BS obtuse, again the centroid lies inside the triangle. You can observe here. If I can make angle C as obtuse, Again, you can see here angle C is 131.81 degrees. Again, the center lies inside the triangle. That is whether triangle is acute angle triangle or whether triangle is obtuse angle triangle or whether triangle is a right angle triangle. Okay, you can see here this is around 97. Angle B is approximately 87.90 degrees. Okay, so you can calculate the angle C. Okay, angle C is this one. Okay, so in this way, whether the triangle is acute angle triangle, whether the triangle is obtuse angle triangle, whether the triangle is right angle triangle, center always lies inside the triangle. Okay, so for your convenience, what I am doing is I am just erasing these lines. Okay, display height segments. So in this triangle ABC, DEF are the midpoints, G is the centroid. So now what I am doing is we are verifying that circumcircle, or you can say we can just find out the orthocenter first. Okay, so what I am doing is I am just drawing the altitudes from A to the side BC. From A, I just selected the point A and selected this line BC. Okay, I am just drawing the perpendicular line. So you can take the point of intersection. Okay, again I just chosen B point and line say AC and drawn the perpendicular here. Okay, these are the two altitudes. I am taking their point of intersection and denoting this as point H. So in this triangle ABC, DEF are the midpoints, G is the centroid, and H is the orthocenter. And for your convenience, let us take this point as we are marking this point. As per my convenience, I can choose any other point. So I am choosing this point as X. Okay. That is AX is perpendicular to BC. You can say as AX is perpendicular to BC. So now I am taking the intersection of these two lines. Okay. We can go to construct and just select the intersection. Now I am naming this point as capital Y, so that we can know that in triangle ABC, AX and BY are the altitudes and their point of intersection is H. Okay. So if I have to verify that in a triangle all the altitudes are concurrent. Altitudes means if I draw perpendicular from the vertex A to the side BC, is called the altitude. AX is called the altitude, BY is another altitude, their point of intersection is H, which is called the orthocenter. Okay, orthocenter of a triangle. Now if I have to verify that in a triangle all the altitudes are concurrent or not, so what I am doing is I just selected the point C and selected this line AB. Now I am drawing the perpendicular. So if it passes through H, I have chosen the point C and chosen the line AB because I am drawing perpendicular from C to the line AB. If it passes through H, it means all the altitudes are concurrent. So let's see what happens. As you are observing that this line is passes through H, so I am taking one more intersection point of these two lines, and we will name this point as Z. You can say Z. Okay. So in triangle ABC, X y Z are the feet of the perpendiculars. Okay. You can verify here. Okay. You can easily verify. But one more important result I would like to mention is that here angle BAC is 71.23 degrees. This is, you can say, 70.07 degrees, and angle BAC is 38.70 degrees. That is, if the triangle is an acute angle triangle, if the triangle is an acute angle triangle, then the orthocenter lies inside the triangle. Okay. So when you make angle B as 90 degree, let's see what is happening. As I make angle B as 90 degree, let's see where the orthocenter H is approaching. So you have observed that as angle B is 90.02 degrees, H approaches to the point B. That is, in a right angle triangle, right angle at B, the orthocenter H coincides with B. यानी कि बेटा किसी भी right angle triangle के अंदर ABC is a right angle triangle. So if the right angle is at B, then B will be the orthocenter of a triangle ABC. So if I make angle B as obtuse, let's see where the orthocenter H is moving. Okay, you can shift here to see easily. Okay, as angle B is obtuse, you can observe here that as angle B is obtuse, so H lies behind angle B. Hope it is clear to all of you. Once again, I am telling you that if triangle ABC is acute angle triangle, you can observe here as all the angles are less than 90 degrees, the orthocenter H lies inside the triangle. As I make angle B as 90 degrees, H goes to the point B. Okay, 90.11. This I am doing manually. Okay, as angle B is 90 degrees, then H coincides with angle B, and as B is obtuse, then H lies behind angle B. Similarly, if you can observe that, if I can make angle C as 90 degrees, if I can make angle C as 90 degrees, let's see where H is moving. As I move angle C to the 90 degrees, H is approaching towards C. Okay, you can say this is 89.92 degrees. Okay, as I make angle C as 90 degrees, it becomes at angle H becomes at angle C. Okay, so if I make angle C as obtuse, H lies behind angle C. Hope it is clear to all of you. You can see here exactly. This is the exact position. Angle BCA is given to be 90 degrees. That is angle C is 90 degrees. H coincides with C. That is in a right angle triangle ACB. If angle C is 90 degrees, H coincides with point C. Okay, better. So if I make angle A as 90 degrees, you can see here as if I can make angle A as 90 degrees, let us see what is happening here. H coincides with A. Angle BAC is given to be 90.03 degrees. Okay, so H coincides with A. That is, if in a triangle, angle A is 90 degrees, H coincides with A. So if I make angle A as obtuse, H lies behind A. Hope it is clear to all of you. That is, in triangle ABC, if the triangle is acute angle triangle, H lies inside the triangle. If angle B is 90 degrees, H coincides with B. If angle B is obtuse, H lies behind B. And one more important result I would like to mention here is, in triangle ABC, if there are 4 points A, B, C and H, if there are 4 points A, B, C and H, you can take any of the 3 points. Let us choose A, B and C. The fourth point will be the orthocenter. That is, in triangle ABC, H is the orthocenter, and in triangle ABH, C is the orthocenter. In triangle ABH, C is the orthocenter. You can verify here as, if I draw perpendicular from A to BH, this is a perpendicular, it approaches to the point C. Again, if I draw perpendicular from B to AH, then this is the altitude, so BX produces to the point C, and the point of intersection is C. Again, CX, that is coinciding. Okay, by chance here F is coinciding, you can see diagram here. Okay, H is a different point, and this is a different point. Okay, in triangle AHB, C is the orthocenter. In triangle BHC, A is the orthocenter. We will prove the results. Okay, and in triangle AHC, B is the orthocenter. And one more important result I would like to mention here is, if I can take the 3 points X, Y, Z, these 3 points, okay, X, Y, Z, I just selected these 3 points, I join these segments. Now this triangle X, Y, Z is called the orthic triangle. In triangle ABC, AX, BY, CZ are the altitudes. Okay, their point of intersection is H, and XYZ is called the orthic triangle. Okay, and in triangle ABC, the orthocenter H of a triangle ABC will become the in-center of the orthic triangle XYZ. We will prove this result. I can verify this result right now, and we will prove these results. There is a simple one. What I would like to mention again is that XYZ is called the orthic triangle, and the orthocenter H of triangle ABC will become the in-center of triangle XYZ. You can verify here as, from H I just draw the perpendicular on XY. Okay, I just drawn the perpendicular on XY, and I am taking the intersection point. Okay, now what I am doing is, I am taking this as a center and this as a radius. I am drawing a circle. Okay, I am just changing its color. Let me do that. And I am erasing this line. This is a perpendicular line. Okay, so you can verify here easily that H becomes the in-center. Okay, but one thing you should note that it is an acute angle triangle. In the acute angle triangle, it becomes the in-circle. when it is obtuse angle triangle, you have to observe what is happening. Basically, it becomes X circle. I will teach you about X circles as well. Okay. So you can mention here that in an acute angle triangle, you can verify here in an acute angle triangle, the orthocenter H becomes the in-center of its orthic triangle XYZ. Okay. In the obtuse angle triangle, H becomes the X center. Okay. We will prove all the results. So hope it is clear to all of you. Now I am just erasing these lines again. So now in this triangle again, what I am doing is I will do some more important results for you. Likewise, I am just erasing these lines right now so that I can teach you some more beautiful concepts. So you can erase, if you want to erase, you can erase these lines as well. Otherwise, we will do some more important results. Okay. I am just erasing these lines. So just joining these lines, AX was the altitude, this was the segment. Okay. BY was another altitude, and CZ was another altitude. All are passes through H. Okay. Again, in this triangle ABC, D, E, F are the midpoints. X, Y, Z are the feet of the perpendicular. H is the orthocenter and G is the centroid. So now we will see about the circumcenter. Circumcenter is a point of intersection of perpendicular bisectors. And the perpendicular bisectors, you can say BC is a line segment, they must pass through the midpoint. So I have just chosen the point D and taking the perpendicular on this line. Okay, this is one of the perpendicular bisector. You can see here this is one of the perpendicular bisector. Just chosen the point E, drawn the perpendicular on the side AC. This is another perpendicular bisector. I am taking their point of intersection. Okay, and naming their point of intersection as, you can say S. S is the circumcenter. And the beauty of perpendicular bisector is, on this line, each point is equidistant from the end points of a line segment. That is the beauty of this line, perpendicular bisector. Perpendicular bisector is a line in which all the points are equidistant from the end points B and C. Okay, perpendicular bisector BC is the locus of all those points, that is a path of all those points, which moves in such a way whose distance from the point B and C is always same. Okay, so similarly, the perpendicular bisector of AC is the locus of all those points which are equidistant from the point A and C. So their point of intersection S. S is the point which lies on the perpendicular bisector of BC. So SB is equal to SC because S is equidistant from B and C. S is the point which lies on the perpendicular bisector of AC. So it means S is also equidistant from A and C. That is SA is equal to SC. From here, SB is equal to SC. From this line, SC is equal to SA. It means S is a point which is equidistant from the vertices of a triangle ABC. So if I take S as a center and SA as a radius, if I draw a circle, you can see it is passes through the point A, B and C. Okay, this is called the circumcircle. This is called the circumcircle, and its radius is called the circumradius. Okay, and its center is called the circumcenter. So here I am just deleting these perpendicular bisectors. In this diagram, I am just deleting these perpendicular bisectors. Okay, so you can easily verify here that in triangle ABC, and you can verify one important result as well. I would like to mention one important result. Here the triangle is acute angle triangle. You can again see this is angle C, this is angle A. You can see here, okay, and this is angle B. So in this figure, ABC is an acute angle triangle. So when ABC is an acute angle triangle, HTS lies inside the triangle. When I make angle B as 90 degree, let's see where H is moving and where S is moving. Or before that, I would like to mention one more important result. If I join H and S, let's see what is happening. It is passes through G as well. That is H, G, S are always collinear, and it is called the Euler line. EULER, Euler line. Okay. So you can verify this result simultaneously. And one more important result I would like to mention again. If I join GH again here, I'm just just measuring its distance, GH. GH is 2.86 centimeter. GS. GS is again 1.40 centimeter. We can calculate GH divided by GS. The ratio is 2:1. So you can verify these results. Okay, that is centroid divide H and S is always in the ratio 2:1, as well as HGS are always collinear. And one more important result is, let's see, when the triangle is acute angle triangle, HGS lies inside the triangle. Let's see what is happening when I am taking angle B as 90 degrees. Let's see where H is moving and where S is moving. You can observe here as angle B is 89.98 degrees. You can observe as angle B is 89.98. You can see that S moves towards E. S becomes the midpoint of AC, and you have seen that in a right angle triangle ABC, AC becomes the diameter, because angle in a semicircle is a right angle. You have seen that in a right angle triangle ABC, AC becomes the diameter, and when AC is the diameter, then the midpoint of the AC will be the center. So that's why S is moving towards E and H is moving towards B. Okay. So when the triangle is acute angle triangle, then all the points HGS lies inside the triangle. When I made angle B as 90 degree, you can see, observe that angle B, H is moving to the point D and S is moving to the point E. Okay, you can see here 90.02 degrees. Angle B is 90.02 degrees. So if I make angle B as obtuse, you can verify that if I make angle B as obtuse, S is moving outside the triangle. Okay, this is one of the important results. You can verify here. If I make some small diagram, okay, you can verify that if I am making angle B as obtuse, okay, angle B is obtuse, then H lies behind B and S lies opposite B. Again, the ratio HG upon HS is always 2:1. You can verify here. Okay, if angle B is obtuse, if this angle B is obtuse, S lies opposite to the obtuse angle and H lies behind the obtuse angle triangle, and always the ratio HG is to GH is always becomes 2:1. Okay, so if I make angle C as 90 degrees, let's see what is happening here. H moves to the point C and S moves towards point F. You can observe here. For your convenience, I can do one more thing. I can erasing these lines, okay, so that it will be more clear to you. I'm just hiding these segments. So in this diagram, you can easily make out that when is angle C is 90 degree, H is moving towards C and S is moving towards F. Easy. 89.93. If I make angle C as 90 degrees, easy better. 89.98. Angle C is 89.98 now. So H becomes the vertex C and S becomes the midpoint of AB. So if I make angle A as 90 degrees, you can see here as if I make angle A as 90 degrees, okay. As angle A becomes 90 degree, H move to the point A and S move to the point D. Hope it is clear to all of you. When angle A is 90 degrees, then H moves to becomes point A and S becomes point D. And if I move angle A as obtuse angle triangle, then H lies behind A and S lies opposite A. And you have seen that angle made by the major arc is obtuse and angle made by the minor arc is acute. Okay, these all results are verified. We will prove all the results as well. Okay. Now I will do 9-point circle. Now I will teach you 9-point circle.